So we just discussed about two variable POS K map. So now we'll discuss about 3 variable POS K map. Okay, so the general layout of the K map for both SOP and POS is the same. So the difference lies in the value assignment, binary value assignment to the variables. So this, okay, 3 variables. Let us call this side as A, this side as B. 0 1 0 0 0 1. Important step here, it is 1 1 and then 1 0. Always remember this point, 0 0 0 1 1 1 1 0. Now up to this point the step is the same for both SOP and POS. Here 0 means it is uncomplimented variable, no bar sign, and 1 means complemented, a bar. Similar here, 0 0 means uncomplimented variables with a OR sign, B or C. Here 0 1 it is B or C bar. 1 1 means B bar or C bar, and this is B bar or C. Okay, so here this is 0 0 0, so 0 0 1, so 0 1 1, 0 1 0, so is 1 0 0, 1 0 1, 1 1 1, and this is 1 1 0. The respective values are the same, 0 1 3 2 4 5 7 6. Okay, the difference lies is that this cell here, okay, let's see, this cell, it is represented as A or B or C, 0 0 0. This cell here, that is represented as A bar or B or C, 1 0 0. This is 0, this is 4. Similarly, this cell, it is represented as A bar or B bar or C, which is 1 1 0. Similarly, this cell, it stands for A or B bar or C, which is 0 1 0, which is 2, and so on. Okay, this is max term representation, product of max term POS. Each cell has a particular representation with consideration that the uncomplimented variables with no bar sign, they stand for 0, the complemented variables with bar sign stand for 1, and they are in sum form. Okay, sum form, the max terms. Now if we compare this with the SOP representation, the sum SOP K map, this is POS, the SOP K map, if we compare it, the general layout again it will be the same. A B C 0 1 0 0 0 1 1 1 1 0. Here A 0 means it is a complemented variable with a bar sign, A bar, this is A, opposite to that of POS, and here comes the difference. Here also it will be the same rule, 0 means complemented variable and it will be in product form, AND form. So it will be B bar C bar, B bar C, B C, B C bar. Okay, so again this is 0 1 3 2 4 5 7 6. So here it is also the same thing, 0 0 0 0 0 1 0 1 1 and so on, but here this cell, it stands for A bar, B bar, C bar. Okay, this cell stands for A bar, B bar, C. Okay, 0 0 1, this is 0, this is 1. Similarly, this stands for A bar, B, C. Okay, which is 0 1 1, which is 3 and so on. So again, if we compare each cell of POS with each cell of SOP, if we compare, let us compare the first cell. Okay, first cell, which is A or B or C, and here the first cell is A bar, B bar, C bar. So if we apply De Morgan's theorem here, we'll whole complement this term, we will get A bar, B bar, C bar, De Morgan's theorem application. Now if we do this in this direction also, if we whole complement A bar, B bar, C bar, if we whole complement that, then we'll get A or B or C. So it goes both ways. So if you see each cell, its Boolean representation, whether it is min term or max term, it is the whole complement of the other. Okay, for POS, for each cell, if we whole complement it, the Boolean term will get the equivalent SOP term. Okay, so each max term's whole complement, we get the min term representation, each min term whole complement, we get the max term representation with a simple application of De Morgan's theorem. Okay, so I discussed this point in the 2 variable K map also, and again it is applicable in 3 variable K map, it is also applicable in 4 variable K map also. Okay, so this is the 3 variable POS K map. Okay, this is POS representation, and we just compared it with the SOP representation to know the basic difference between the two. So general layout is the same, it's only the representation of the Boolean variables to form the Boolean terms, max terms in case of POS, min terms in case of SOP. Okay, so this is the general representation of a 3 variable POS K map. Okay.